So could the devastation in Japan pose a risk to America? As we mentioned earlier, experts are expressing concern that the fallout from a nuclear meltdown could endanger the United States if wind blows radiation across the Pacific Ocean. Now, they're also expressing concern about the threat of additional quakes. Here with more on these potential threats, our professor of civil and environmental engineering at UCLA, John Wallace, and back with us is the director of the Heartland Institute, Jay Lehr. John, let me start with you. Is this a threat to the people in California? I know that a lot of people are very concerned, and it appears the winds seem to be blowing in that direction. Is there a problem?
Well, there certainly could be a problem. We all are following it very closely to see exactly what happens, and we kind of have to wait and see exactly what plays out here.
Jay?
I couldn't disagree more. I think there is no chance of a problem, and even to get people concerned thinking there might be because, you know, anything could happen is absolutely wrong. There is really zero chance that any radiation is going to move out of, even if the outer containment structure exploded and move from Japan to the United States and create any health problem whatsoever.
Well, why do you say that, considering the amount of radiation we're talking about would be obviously very significant?
I say that because I've studied every nuclear disaster and incident since the first Nautilus submarine was launched in the 50s and the Shippensport, Pennsylvania nuclear power plant was constructed. I've studied every one of these things, and of course the worst case was Chernobyl. That was the worst disaster imaginable, a level 7 disaster in which there was no containment. There was a total explosion of the whole plant. Everything went up in the air, and there were radiation clouds that traveled a very far distance in the atmosphere, and there was simply no impact from a worst case.
And this
case.
This is a level 4. Could it become a Chernobyl-style level 7?
Not at all. It could become a level 5, but it has not. Level 5 was 3 Mile Island, where we did have a complete meltdown. The nuclear rods totally melted. That is certainly not the case at Fukushima. Yeah. And they sunk to the bottom of the container. They melted 5/8 inch of steel in a 5-inch steel thickness, and it cooled off, and there was no problem.
John, let me go back to you. You came bringing video with us, including a test done at the National Taiwan University to study the performance of reinforced concrete columns, and 2 other videos. Why don't you set it up for us?
Well, I just wanted to point out the level of testing and research that goes into trying to understand how to improve the quality of construction. These tests were done at National Taiwan University, and the other test was actually done at the E-Defense facility in outside of Kobe, Japan. The other thing is that U.S. researchers spend a lot of time interacting with our colleagues across the world to improve construction. And
yeah, but look, can you tell us what we're looking at in these videos, though, John? I mean, obviously, it's I assume it's a mock-up of an earthquake and structural issues, correct?
That's correct. It's a table, a shaking table that simulates an earthquake load. And that causes the columns to sway back and forth. And in one case, they're kind of older buildings that have looked at.
Okay. And but as far as it relates to when you have a full-scale, 8.9, in the case of the Jay, I'll go to you on this. They were these facilities, as well as the fact they were built decades ago, were prepared for an 8.2 magnitude earthquake. So it seems like. Go ahead.
It's astounding, Sean, considering the fact they built for an 8.2, they had a 9.0. The plant is 40 years old. We have safety mechanisms far above what were ever originally constructed, although the plant was upgraded. It was going to be taken out of operation in the near term, and yet with that all, the Japanese engineers have really been able to manage this. What they call a meltdown is an exposure of the rods, a heating that isn't yet brought under control. It's just residual decay. It's going to be under control in a few days.
Do we have any concerns?
No reason for concern.
Is there? And what about the concern of an aftershock that is of significant magnitude? Do we then have to worry of additional damage?
No, because once it's cooled down, that's it. The radioactive chain reaction is over. We do not have to worry about an aftershock, let's say a week or 2 from now.
All right, guys, thank you all both for being with us. And coming up in the wake of the devastating earthquake in Japan, people are asking, where will the next quake strike? We're going to look at the likelihood that one could hit the U.S. coming up next. All right, now the tragic images coming out of Japan after Friday's horrific earthquake and tsunami only remind us here at home that disaster can strike anywhere at any time, and many people are speculating about where the next big natural disaster will hit and wondering if it could happen here in the U.S. Joining me now to talk about how concerned we should be here in America is the Vice President of Earthquake Risk Applications, Mary Lou Zobak is with us. Mary Lou, you think that, in fact, we are not doing enough to prepare for a potential earthquake, and that you know that there are a lot of buildings of both northern and southern California along the San Andreas fault line that you know will collapse, and we're doing nothing to stop it, correct?
That's true. In both northern and southern California, particularly in the urban core, there's many older buildings and they're seismically vulnerable. We know this, but we're not doing anything about it.
So are you suggesting that it would be catastrophic and we have advance warning? In other words, that a major earthquake in California is not if, but when?
Well, I think almost everyone that lives in California knows it's a matter of when, not if. But unlike hurricanes, we won't have any warning at all. This next earthquake that strikes us, it may hit northern, it may hit southern California, it may be in the Pacific Northwest, but we won't have any warning. So there's not much we could do. And even if we knew a day in advance, that's not going to keep the buildings up. There's nothing we can do to strengthen them.
But let's look at the danger in California, for example. We have a map that shows the likelihood of a major earthquake in the next 30 years in California, and it shows where the threat would be greatest, which my reading of this map is Southern California. Can you explain what's on that map?
That's true. The warm colors, the reds and oranges, are primarily where the earthquake threat is the greatest and primarily along the major faults that we've identified. And basically, the way the map's created, we have evidence from past earthquakes, basically digging trenches across faults, and that gives us an idea on average how often earthquakes occur, which is typically every several hundred years. In Southern California, on the San Andreas Fault, it's been 300 years since the last big earthquake on the San Andreas Fault.
So you're saying California on the San Andreas Fault is due just based on
Southern California
Go ahead.
is overdue.
Overdue. Now,
overdue.
Yeah, go ahead.
Well, on average, there's a major earthquake about every 150 years, and it's been 300 years since the last one.
Does that increase the likelihood that it would be that much more devastating?
That's correct. The longer we go between earthquakes, the more stress builds up, and the chance of a larger earthquake is very real.
What magnitude are we talking about?
Well, we think that if the whole southern San Andreas Fault breaks, it'll be about a magnitude 8 earthquake, similar to what the 1906 earthquake was in Northern California.
Mm-hmm. Well, we actually have a mock-up of that in Silicon Valley earthquake, and this was 1906, and it's sort of a recreation. Can you walk us through this?
Yeah, this is a computer simulation done by scientists at the U.S. Geological Survey. They basically recreated the earthquake, propagated the seismic waves through the Earth's crust, and what we're looking at, we're sitting up in a hot air balloon above San Jose, above Silicon Valley. We're watching the earthquake come towards us from San Francisco, which is at the top of the screen, and this is in real time. Earthquake waves, the first wave, which is traveling in blue, travels about 14,000 miles an hour. The really strong shaking in yellow and orange travels more like 7,000 miles an hour. Yeah. But what you can see in Silicon Valley is that the ground just keeps shaking. It looks like Jell-O in a bowl, and that goes on for many tens of seconds.
Let me go to the state of Washington, where many scientists believe an earthquake similar to what happened in Japan is going to happen there. And they say there's a 20% chance it'll happen in the next 30 years. Explain what we have in the state of Washington and the risk there.
Okay, underneath the entire Pacific Northwest, beneath the state of Washington, Oregon, and northernmost California, we have the oceanic plate diving beneath the continent, just like in Japan. We expect an earthquake of almost the identical magnitude, magnitude 9. And when that earthquake occurs, we're going to see very similar effects, and we're going to see a huge tsunami. And it's not going to be very different than what we've just witnessed in Japan.
Look, we've seen the tsunamis in Indonesia, now Japan. We don't have a lot of time here. What would a tsunami in either California or the state of Washington look like? How far inland would it go?
For the communities along the coast, they've done some calculations. The wave could be as high as 80 feet. It'll be very powerful. And even cities like Seattle that are way inland are not exempt. There's a strait, the Juan de Fuca Strait.
Right.
And they've actually done models showing the waves could come in that strait.
We've got to run. Appreciate your time. That's all the time we have left this evening. Thanks for being with us. Greta's next. We'll see you tomorrow night.